For loops. We're going to learn about two different kinds of loops. We'll start out with what we call for loops. A for loop is of the form for followed by a variable name, in, and then a collection or list of values such as range, for x in range. Now let's look what this does here. Right here we'll say for x in range, say from 5 to 8. Let's just go ahead and print x. When we run that, we see x takes on the values 5, 6, and 7. So it loops, this code does, through the body of the loop, repeatedly setting the variable x equal to each value in turn inside this range. Now, range does not include its right value, its endpoint, but it does start at 5. So if we want to go from 5 to 10, we would not go from 5 to 10, but from 5 to 11. And this body then would be executed 6 times, where x equals 5, 6, 7, 8, 9, and 10. So let's look at how we can use a range. We can sum the values from m to n. And the way we would do that is we'd keep a total, a running tally of the sum. We'd have x go through the range. X will be m, m plus 1, m plus 2. And each time we get a new x, all we're going to do is add x into our total. When we're done, we return our total. And like that, we see that the sum from m to n from 5 to 10 indeed is 5 plus 6 plus 7 plus 8 plus 9 plus 10. So this tally or running total is a common technique for gathering results as you move through a for loop. It turns out we don't actually need a for loop here for two different reasons. One way we can do this would be to directly sum the range, which is legal to do. So over here to show you, we can say, for instance, print sum of range 5, 10, and that will print the sum of 5 plus 6 plus 7 plus 8 plus 9, 35. Okay, so you can do a sum of a range. And also, it turns out there is a closed form solution. There's just a formula. The way we would do this is we'll use the formula from the sum to n, well known, n times n plus 1 over 2. And then we'll call it twice. To sum to n, we'll take this from m to n, we'll take the sum all the way to n. So that's 1 plus 2 plus 3 all the way up to n. Then we'll subtract out the sum to m minus 1. For example, if we're summing from 5 to 10, what that would say to do is add up all the numbers to 10, but subtract out all the numbers up to 4, leaving just the numbers from 5 to 10. And if we run this, we see that, in fact, that works as we would hope. So the point of this entire block here is that sum from m to n is a nice little example to show you how a for loop works. But in practice, if you actually had to write sum from m to n, you probably would not use a loop. All right, so now in the range up here, we use two parameters, the starting point and the ending point, where the starting point is inclusive and the ending is exclusive. You can leave off the starting point and just use the ending point, in which case it starts from 0. So if you just say range here of, say, print sum range of 5, that's the same as printing the sum of range from 0 to 5, which of course doesn't include 5 at all. It's 1 plus 2 plus 3 plus 4. Okay? That is the first parameter. If you leave it off, it defaults to 0. You can add a third parameter to the range. There's our third parameter. It's called step. So we could print the range from 0 up to 10 by 3s. And that would print 0 plus 3 plus 6 plus 9, which is 18. So it's the step. So by stepping by k, we'll do every kth number from m to n. And then if you want to just do the odds, for example, let's look at a couple ways to do this. One way to do this is if we want to just do the odds from m to n, is to walk through every number from m to n. So far, so good. And then, if that number is odd, go ahead and add it into the total. This works. It's fine. So another way to go about doing this, though, instead of going through every number and then checking if it's odd, we could use the step to only go through the odd numbers. So we'll step by 2s. The thing about stepping by 2s is you have to make sure that you start on an odd, otherwise you'd be stepping through the evens. So If we're starting on an even, we add 1 to make sure that we're starting on an odd. At that point, we can start at m, which is the lowest odd in our range, and step by 2s. And finally, another way we can do this would be to go in reverse, starting at the end and going by -2s. This is a bad idea, I believe. It's confusing to have ranges with negative steps. There might be times you have to do that, but if you don't have to, it's good to avoid doing that and just have positive steps. I think it's much more intuitive. And then finally, it turns out we can kind of collapse all this logic more tightly here by using the sum instead of the loop like we saw above. And then finally, even one more time, and this is just terrible, but to show you what you can do, we can do it all in one shot by having the sum. We'll go ahead and arrange here, but notice here we're starting at m that was adjusted to start on an odd, and we can do that adjustment in place. And this basically says if m is even, start at m plus 1, and if m is odd, start at m. This code right here works. Run, see, huzzah, it works. But it's really bad code. It's complicated. There's too much going on in one line of code. And I would strongly recommend using one of the other forms above. And in fact, if I were writing this code, frankly, well, I would use a closed form solution. But shy of a closed form solution, I would actually probably tend to use the stepping every one, or for efficiency, do the most basic kind of stepping through the odds. In any case, that's the starting point for dealing with for loops.